Okay, in this video now we will be looking at a very simple switch, because before I move on to rearrangeably non-blocking switch I would like to do this. So, we would like to build the switch with which is a 4 by 4, this is the simplest switch which we can get, and I want to build up a closed network. So, I am not going to build a strictly non-blocking switch here this time, but this will be a rearrangeably non-blocking switch, and I will give the connection setup algorithm in this case. So, this is the way it is built. You can appreciate that this is a closed network. In fact, this kind of configuration becomes the Bayes network. I can actually, has been a 4 by 4 switch, okay. But remember, this is a blocking switch. So, I can show you how the blocking happens and how this can actually be resolved, and then we will look into how we will recursively construct. So, this in fact is a subclass of closed network, we call it Bayes. Okay. So, this is in the honor of V. E. Bayes. So, this 4 by 4. So, first of all I have to give you the algorithm by which I will be able to set up any kind of connection within this switch. So far we do it that way, okay. So, let us try to set up a connection. So, I can take an arbitrary map, okay. So, how we will do it? So, we can try it out. So, one I can set up through upper root, okay, 4 to 1 for example, like 3 to 4 prime I can set it up in this fashion, okay. So, I have set this one up. I have done it intentionally in a certain sequence, so that you can actually see the blocking is happening, okay. So, now can I set it up 2 to 3? I try it out. So, 2 to 3 only way I can connect through this route, but I have no path to 3. I can actually set up only 2 to 1 prime, or I can set up only from 4 to 3 prime. So, connection is not possible. So, what to do in this case? This is a blocking system. But if I would have been intelligent enough to actually switch it to do it in a different way, I would have set up still a 3 to 4 prime, and then I could have done 2 to 3 also. And 4 to 1. So, all 4 connections are through now, okay. But then how not to make this kind of mistake which I did? So, in this kind of network the logic is very simple. I can create a loop. The way I should actually set up the connection, we call it a looping algorithm. So, I will start with a fresh and use my looping algorithm. Looping algorithm says that I should, so these two belongs to same switch, these two belongs to same switch, these two belongs to same switch, these two belongs to the same switch, okay. So, I will start with one, I will set up the connection, I can do it the way I want, does not matter, okay. This is the first one. So, if I set it up like this time I am doing it in different way. So, 1 to 2 prime, and I have set up the connection. So, the next connection should be set up from 1 prime. So, 1 prime has to connect to 4. So, 1 prime to 4 I should set up the connection, okay. So, 1 prime to 4 or 4 to 1 prime. So, when I do it, I can actually use, when I am going forward I should either use bottom switch or the upper switch, but while coming on the reverse direction I should use the other one, okay. So, since from 1 to 2 I have used the upper one, So, from 1 prime to 4 I should use the lower one, I have used the lower one, sorry, here I should use the upper one now. So, I have to use this option. In fact, I cannot use the lower one, it was not possible even if I would have tried. So, it has to be from the upper one. So, I have come to the 4. So, for the corresponding switch, the input in the same switch is 3. So, I should set up 3 to 4. Since I am going in forward direction now, I should use the lower switch now. Okay. So, I will be using lower one and connect to the 4 prime, and now I should connect to 3 prime. I am coming back, 2 to 3 prime has to be from the upper one. So, 2 to 3 prime will be through upper one. I will be always be able to set up the path in this 4 by 4. I can actually now create even a larger dimensional switch. How to do that? I have already 4 by 4, and if I follow this algorithm I will be able to set up the path. Whatever be the connection, whatever map you take, I will always be able to set up the path. We can try out some other arbitrary example also to satisfy to verify this thing. Yes. So, we will now set up another connection. So, I can take a different map and I will use the same logic. So, I can try out this. Okay. So, 1 to 3 prime, and this time I am going to go from upper actually. So, this time I will try first upper. So, 1 to 3 prime goes here. So, corresponding to 3 prime there is a 4 prime. So, I need to create 2 to 4. So, 2 to 4, but I will be using lower one. Okay. 2 to 4 is a lower one. So, in fact, the loop started from here, went and came back here. So, loop actually is complete. So, but I can actually then choose 3 and 4, again following the same logic, 3 to 1. If I am taking, I am going to take upper one because the loop is complete. So, this time I can start from any one of these. So, I can take either this as upper and then keep on doing the loop. So, then can be multiple loops which can exist. So, we will now do it for a larger dimensional switch also. So, 3 to 1 I will take upper, and then 4 to 2 I have to take lower one. Connection is set up. Okay. So, you take any combination, this will be feasible. Now, can I make a bigger switch by using same thing? So, Bayes network actually is built by 2 by 2, these are 2 by 2 crossbar. Okay. Clause is a more generalized form. So, this is subclass of a clause. So, I can now I can create this 4 by 4, and I have two by 2. So, this becomes 8 by 8 switch. So, one goes up, one down, one goes up, one down, one goes up, down. We have got a 8 by 8 switch, and we can do a similar exercise here also. Later on, when we will actually do a slip and Dewey theorem, we will understand why this thing is working. So, we just have to bother about the looping. So far we do the looping correctly, we will be always be able to set up the path. Okay. and there will not be any blocking scenario. Okay. So, you can take arbitrarily any connection. So, I have done something arbitrary here. Okay. So, 1 to 8 I want to create. So, if I go in forward direction, I have to either decide that it will be upper or lower. Okay. So, this can be upper or this can be lower. So, if I decide it is going to be upper one in the forward direction, so 1 to 8. So, I will be switching here, and this can now switch over to the fourth one, and I can connect to 8. Internally this 4 by 4 can be built using this technique, and I can use a looping algorithm here which I had used here internally within this switch block, and I can set up all kind of maps. Every possible map can be done, but remember this is not a strictly non-blocking switch. Okay. The mapping from inputs to output will only be possible for in certain states. In certain states it can become blocking. I have shown with an example in the beginning. Okay. So, once it goes to 8, so corresponding is 7. So, which means 4 to 7 has to be happen from the bottom one. So, I will take the bottom one 4 to 7, and connection has been done. So, I have done 1 to 8, 8 the corresponding was 7. So, I have finished this. So, once I have come here, the corresponding to 4 I have 3. So, 3 is this, 3 to 6 prime, this has to go from the upper one, 3 to 6 prime it has to come here, 3 to 6 prime it goes connected, 6 prime the corresponding number is 5. So, 8 to 5 has to go from bottom. So, remember this is the forward direction, this is the reverse, this is the forward, this is the reverse, 8 to 5 has to go from bottom, 8 to 5 has to go from bottom. Okay, done. Corresponding to 8 is 7, this has to happen in the reverse forward direction from the upper one, 7 to 3 prime. So, connection is through. Corresponding to 3 there is a 4, so 6 to 4 has to happen in the backward direction from the bottom one. So, 6 to 4 I will do it through bottom one. So, this is done. Corresponding to 6 there is a 5. So, 5 to 1 prime has to happen in the from through upper in the forward direction. So, 5 through upper it goes to 1. So, this is done. Corresponding to 1 there is a 2, 2 has to be connected to 2 prime, but through a bottom route. So, 2 will be connected via bottom route. I have set up all possible connections. I can actually keep on doing it. I can make now using this 8 by 8 block, 2 8 by 8, and I can put 4 switches here, 4 switches here. Similar kind of thing on this side, it becomes a 16 by 16 bins network. Okay. Bins network basically I have to replace this by here. I am showing 4 by 4 block, but actually bins network will be requiring 3 stages of 2 by 2 here. Okay. So, again I can use this looping algorithm and set up the paths there, and there will not be any blocking so far. You follow this procedure. Okay. The looping thing is taken care of. Okay. So, but I have also told you about pulse matrix. Let us see what happens in the pulse matrix when I am doing all this. So, let us draw the pulse matrix for this one. So, I have how many switches here? There are only 2 switches, it is a 2 by 2 matrix. So when I create it from 1 to 3, so I am creating 1 to 3, so this 2 switches, so first row second column which is this one, I have used, I will define this as upper and lower. So I have used the lower one, upper one, so 1 to 3, and then for 2 to 4 I have used the lower one, okay, this also comes here, then 3 to 1 I have used upper, and 4 to 2 I have used lower. The condition is satisfied. Build up a pulse matrix for this one. So I will be requiring, in this case 4 by 4, only 2 switches are there, upper and lower. So from 1, when I am connecting to 8 prime, so this is going from row 1 to column 4, this is going via upper, okay. So 1 to 8 prime, and when I am actually connecting from 4 to 7 prime, this is going from bottom, which is this switch 4 to 7 prime. So I am going here, 4 will be here, so I am actually putting up a lower here 4 to 7 prime, okay. And then I am doing uh, 3 to 6 prime. So 3 stands here, 6 comes here, I am using the upper part. So remember, this is the way I am going, and then I am using 5 prime being connected, 8 to 5 prime. So 5 stands here and 8 comes here, so I am putting a lower here, 8 to 5 prime, that is a bottom part, and then 7 to 3 prime. So 7 comes here, 3 comes here, I am using upper. So I am, you see, I am actually making a chain, that is what the loop is. So 7 to 3 prime, then 7 to 3 prime, then comes the 6 to 4 prime. So 6 will come here, 4 prime here, so lower, so I am coming here, and then 5 to 1 prime. So 5 comes here and 1 prime comes here, so upper, and then 2 prime to 2 prime. So 2 comes here, 2 comes here, so I will make lower. I started from here, I came here, and these two are also not conflicting. So I built up the complete loop. There is one single loop which has been done. So that is what is happening in the pulse matrix. Same will be true if I make it for a 16 by 16 and so on. So in the next video we will actually formally look how to prove this particular thing. For 2 by 2 life is very simple, I can actually show it. So far I am doing this, this is okay. But if I am not using 2 by 2, is there a generalized number of switches, what will be the condition for rearrangeably non-blocking system? This is a rearrangeably non-blocking system actually. This is not a strictly non-blocking, because blocking states do exist. But if you set up the connections, or you can rearrange the connections, some existing connections can be moved, but how they should be moved, that I have not discussed here, okay. So the rearrangement strategy as well as the proof for a generalized system, we will do it in the next video.